Why your always-on network is charging you every minute you sleep. You turned off the TV. You locked the door. You turned off the lights. You went to bed. And your house stayed awake. In the living room, a router kept transmitting radio waves. In a cabinet, a smart TV kept listening for a wake signal. In a closet, a NAS drive kept spinning at 7,200 revolutions per minute. In the hallway, an IoT hub kept checking in with a cloud server 5,000 miles away. Nothing looked active. Nothing looked broken. Nothing looked urgent. But electricity was still flowing. Heat was still being generated. Wear was still accumulating. And your bill was still ticking upward. This is not about gadgets being bad. This is about a hidden system cost that never sleeps. Look at your home network. It feels passive. It feels invisible. It feels like background infrastructure, the way water pipes or electrical wiring are. You assume it just exists, but it is not passive. It is a 24/7 industrial process disguised as convenience. You did not choose this consciously. It came bundled with smart devices, instant wake features, remote access, and seamless apps. You bought convenience. The invoice arrived quietly, paid minute by minute, hour by hour, while you sleep. That invoice is what this video is about. Most people think of energy use as something that happens when they are actively using a device. Lights on, TV playing, air conditioner running. The assumption is simple. If I am not using it, it is basically off. That assumption is wrong. Mechanically and electrically, it is dangerously wrong. Your home network lives in a permanent state called active standby. Not fully on. Not fully off. Always alert. Always connected. Always processing. From the outside, that looks harmless. From the inside, it is a constant workload. Let's start with the heart of the system, your router. Your router is not a dumb box that only works when you stream a video. It is a miniature data center that never rests. Even when no one is home, your router is working harder than you think. Every 100 milliseconds, it broadcasts a beacon frame. This is a radio signal that announces the network's existence to the world. I am here. My name is network name. My security is WPA2. It does this 10 times a second, 600 times a minute, 864,000 times a day. Simultaneously, it maintains a NAT table, network address translation. It keeps a live database of every device connection, mapping internal IP addresses to the external internet. It runs a firewall, inspecting thousands of incoming packets for threats. It negotiates encryption keys with your ISP. Even at 3 a.m., when your house is silent, your router is exchanging keep alive packets. These are tiny bursts of data sent to external servers. They serve one purpose, to say, I am still here. Do not drop my connection. Each packet is small. But to send it, the router's radio must wake up. The processor must calculate the checksum. The power supply must convert AC to DC. That means the power drawn never goes to zero. It oscillates constantly, small spikes, hundreds of times per hour. Most people never see this because their electricity meter averages the usage. But over months and years, those spikes add up to a significant baseline load. You are paying for a network that never sleeps. Now, consider your smart TV. You probably turned it off with a remote. The screen went black. The LED turned red. You assumed it was off. But modern TVs rarely shut down completely. They enter a warm boot state so they can turn on instantly when you press the button tomorrow. In this state, several systems remain fully active, The Wi-Fi module stays powered to listen for wake-on-land magic packets. The main processor remains partially awake to run the OS kernel. Voice assistants, like Alexa or Google Assistant, stay ready, listening for a keyword. The TV periodically checks for firmware updates. It syncs usage data with the manufacturer's servers. From your perspective, nothing is happening. From the TV's perspective, it is working. That standby draw might be 15 to 20 watts. That sounds small, but it runs every hour of every day, 365 days a year. More importantly, that constant partial activity generates heat. Heat is the enemy of capacitors and solder joints. Electronics degrade faster at elevated temperatures. So you are not just paying for the electricity. You are slowly aging the device itself. Now, let's look at the heavy machinery, the NAS, Network Attached Storage. A NAS is a home server for storage, photos, backups, media. People buy them because they feel safer than cloud storage. It's my data in my house. But most NAS devices are designed to stay powered on permanently. Inside, mechanical hard drives spin at 5,400 or 7,200 revolutions per minute. Cooling fans run continuously to keep the drives safe. The CPU handles background indexing, RAID parity checks, and remote access protocols. Even if you access it once a week, the system assumes you might need it at any second. Spinning disks are mechanical devices. They rely on physical bearings. Bearings wear out based on hours of operation, not how often you read a file. A hard drive rated for 50,000 hours will reach that limit in about 5.7 years of 24/7 operation. If you only use the NAS for 2 hours a week, but leave it on 24/7, you are wasting 98% of the drive's mechanical life on idle time. You are burning through the hardware's lifespan just to keep it ready. Again, this is not a failure. It is how the system is designed to behave. It prioritizes readiness over longevity. Next, consider the invisible army, IoT hubs, and smart devices. Smart bulbs, cameras, doorbells, sensors, thermostats. All of them rely on constant connectivity. They communicate via Wi-Fi, Zigbee, or Z-Wave. They stay in a low-power listening mode, waiting for a command. They periodically sync state data with cloud servers. The temperature is 22 degrees. The door is closed. The light is off. Each device may consume only 1 or 2 watts. But your house likely has many of them. 5 devices become 10. 10 become 20. 20 become 40. Individually, they seem insignificant. Collectively, they form a phantom load, a permanent baseline energy consumption that never turns off. You did not install a factory, but your home behaves like one. It has a base load that exists even when the building is empty. Now, let's examine the core mechanic behind all of this. Always-on networking. Modern devices assume that internet access is a permanent utility, like gravity or air. So instead of sleeping deeply, they enter shallow standby states. Shallow standby means 1. Processors never fully power down, S0 low power idle. 2. Network radios remain locked to the access point. 3. Memory stays refreshed, self-refresh mode. 4. Encryption keys remain cached. This design is optimized for one thing: latency, instant response. Tap your phone, and the light turns on in 200 milliseconds. Say a wake word, and the assistant replies in 1 second. Open an app, and the camera feed loads instantly. That instant convenience feels magical. But physics demands a price for magic. The hidden trade-off is simple. Zero latency equals constant energy. Speed today equals energy use every second of every day. Let's translate this into the invoice. There are two invoices in your always-on network. Invoice number 1. The electricity bill. A powerful Wi-Fi 6 router might draw 15 watts continuously. A smart TV in active standby might draw 20 watts. A 4-bay NAS might draw 50 watts. Add 20 smart bulbs and hubs at 1 watt each equals 20 watts. Total baseline, 105 watts. That is 0.1 kilowatts running 24/7. 2.5 kilowatt hours per day. 912 kilowatt hour per year, depending on your local electricity rates. That is $150 to $300 a year. Just to keep the house ready. You are paying the equivalent of running a refrigerator just for internet readiness. You did not choose that explicitly. It was baked into the design of smart living. Invoice number 2. Hardware aging. Heat is the ultimate enemy of silicon. Every hour that a chip runs warm shortens its lifespan due to electromigration. Routers run hot because they are enclosed, compact, and constantly processing radio signals. Smart TVs generate heat internally because their power supply units, PSU, remain energized. NAS drives generate friction heat. Over years, this accelerates wear. Electrolytic capacitors dry out. Solder joints crack from thermal cycling. Bearings seize up. Nothing fails suddenly, but devices need replacement sooner than they otherwise would. You are trading instant readiness for long-term durability. Now consider the network itself as a system. Your internet service provider, ISP, assumes your connection is always active. Cloud services assume your devices are always online. App developers assume they can push an update at 4 a.m. This creates a feedback loop. Devices stay online - services build features that rely on it - devices must stay online even more. You are not just running a home network. You are a node in a global machine that expects your house to be always awake. And that machine is not optimized for your bill. So what happens if you actually turn things off? Here is the uncomfortable reality. If you unplug your router every night, you break that seamless experience. Your TV will complain about no network when you turn it on. Your smart bulbs will flash to reconnect. Your phone won't back up your photos automatically. Your NAS won't be accessible when you are at work. The system was designed to make off inconvenient. That is not a conspiracy. It is a design choice that prioritizes frictionless user experience over energy efficiency. Convenience is the product. Energy is the byproduct. But you do not have to accept the full cost. There is a middle ground between total disconnection and total always on. Step 1. Segment your network. Not every device needs 24/7 connectivity. Routers must stay on. They are the gateway. But peripherals do not. Put smart TVs, soundbars, and game consoles on a smart power strip. Set that strip to cut power at 1 a.m. or when you leave for work. This forces them into a cold-off state. It saves energy and clears the RAM, often fixing bugs. Step 2. Schedule your NAS. Most NAS systems, Synology, QNAP, have a power schedule feature. Configure it to sleep from 1 a.m. to 7 a.m. Configure it to hibernate hard drives after 20 minutes of inactivity. If you need remote access, use Wake on LAN only when necessary. This dramatically reduces drive wear and energy use. Step 3. Audit your IoT. Do you really need a smart Wi-Fi plug for the coffee maker? Do you really need the smart speaker in the guest room? Every device you remove lowers the baseline load. Turn off always listening features if you don't use them. Disable automatic updates and run them manually once a month. The key idea is this: your home does not need to be a data center. Instant response is a luxury, and every luxury costs something. You are paying either in electricity today or in hardware lifespan tomorrow. Most people accept always-on networking as inevitable. They treat it like the weather, something they cannot control. But it is a choice. You can keep everything awake, or you can decide when your house truly sleeps. The network is not evil. It is not broken. It is simply doing exactly what it was designed to do. It is maximizing readiness. The cost is predictable. The choice is yours. Right now, as you watch this, your house is still awake. Packets are still flowing. Fans are still spinning. Chips are still warm. You are paying for that silence. Not loudly, not dramatically, but steadily. And the meter is ticking,